In this question, we are going to look at how to solve this question displayed on your screen. The question is from Friction, but question is from under the pooling system. Now, how are we going to solve this question? Looking at this question, we have to find the normal reaction on the surface, and we have to find the frictional force between A and the surface, and third, we are asked to find the tension in the string, and fourth, we are asked to find the common acceleration of A and B, given that G is equal to 10 meters per second. To solve this question, remember, as we always do, solution. Now, there is something very important in order to be able to solve this question. Now, we are going to analyze the diagram given to us. If you look at this question very well, you will see that here a mass is given here, and the mass is 10 kg, is A, and is 10 kg. Now, here we are given a pooling system. This is a pooling system. This is a string. Now, the two mass given in the diagram are given. A is 10 kg while B is 15 kg. So this is a rough surface. The first question asks us to calculate the normal reaction on A. Now, before we proceed with the calculation of the question, let's first of all analyze this mass first. This mass, let's take it out. Let's have it to be, this is it now. We have A. We want to look at the forces that act on it. You will realize that this object on this rough surface, is exerting a weight on that rough surface. So let's have it. So how is the direction of the weight exerted by that mass on the rough surface? It is coming like this. Do you get the point? It is coming like this. So let's tag it to be what? W. Are you getting my point? The weight is coming downward. Now, if you look at this, the rough surface too is exerting a weight on this rough surface, is also exerting its own weight, its own force, let me put it that way, on this object A. Now, that is going to be your normal reaction of receive on A. Now, and that's going to be what? R. Now, remember that this object, there is here, the object is moving along this direction. Because of this mass is heavier than the one of B is heavier than the one of what? A. Now, if you look at this question very well, you realize that as soon as this one is being attached to the system, it has the capability of pulling the system downward like this. Now, what happened here? There must be a frictional force that will be trying to oppose this movement. That frictional force will be trying to oppose this movement of what? Object A. And that was why this is being put in that what? Diagram. That means, what's the frictional force? If the object is moving along this direction, then frictional force will be like this. So here, the frictional force, that's FF, is frictional force. It's moving in this direction. Now, look at this very well. This one, as the object is moving this direction, it is this one that caused the movement. Now, remember, it is the tension here, the tension between this and this, that will cause the movement of this, and the tension is being produced by this. Now, the tension is moving in this way. So tension is moving in this way. That is F of what? T. Let's tag that to be F of T. Now, we've analyzed this one now. Now, let's analyze this second one. That is for mass B. So it is in this form, right? Remember that this one is only this one. This arrow showing that the weight of this object will be coming downward. That is, weight of this one is coming downward. While the tension is the one that is the tension here. The tension is upward here. The tension. that is the tension in the string is upward. That is, this one is trying to draw this one back. So that is the tension produced by this one now, by this object on this. This object A is producing a tension along this rope on this. That is, the tension will be in this form. So this one, the tension will be like this. That is, F of T will be like this. It will be going upward. While the tension produced by this one is just by B, is the one that is pulling this object forward. So now, having analyzed the two masses that are given in the question, let's solve the first question 1. The first question 1 solution is very simple. So we are asked to find the normal reaction. The normal reaction, as we all know now, you know the formula to the what? R is equal to mg, because it is the normal reaction on A that we are looking for, and that's going to give us m. This is the normal reaction. Are you getting my point? Remember, in the diagram, that's R is equal to mag. So what's our m? Is normal reaction on A that we are looking for. And what's the mass of A? The mass is what? 10. So that's what? 10 times what? What's G? G is also 10. That's going to give you 100 Newton. That is, the normal reaction is 100 Newton. That's very simple. The second question that we're asked to find is the frictional force. To calculate the frictional force here is very simple also. Remember, this is A. And look at what happened here. The frictional force to calculate, we are given in that question, the coefficient of static friction is given to be 0.5. Now remember that frictional force here, to calculate it, will be equal to F is equal to UKR. That is times the normal reaction on A. And what's that? Is 0.5 is the UK. That is the normal, the frictional, the coefficient of frictional force that is given is 0.5. Then times what? Your R, that is calculated to be 100, times 100. And that's going to give us what? 50 Newton. So the third question asks us to calculate. The third question asks us to calculate the tension in the string, and that's where the real solution is. That place is a bit tough, let me put it that way. Now look at this question very well. If you look at this, my analysis here very well, you realize that in this two forces acted on this object A when it is moving in this direction. When it is moving in this direction, two forces acted upon it. The first force is what? Is friction, and the second one is what? Is the force due to the tension. The force due to the tension. Now, if you look at this diagram very well, for this object to move forward, it means the tension is greater than the frictional force for it to move forward. Now, meaning you are going to look at the sum of the forces that enable this object to move forward, to cause it to accelerate. That's what you are going to consider in order to find the tension. Now, how are we going to do that? Now, some of the forces, addition of all the forces in the diagram, in this diagram, enable this object to move forward. Now, so the sum of the forces is now going to give you sum of force on what? On A. That's going to give you sum of force on A is going to give you the first force, the one that enabled the object to move forward. Now, this tension along this string is greater than this frictional force. That was why this object was able to move forward. Meaning you are going to minus frictional force from what? From the tension, and that is the little amount of force that caused that object to move. Now that is frictional tension minus force due to tension minus frictional force. Now in this now is very simple, and that's what caused the object to what? To accelerate. So if this is the sum of the forces that caused the object A to accelerate, then you remember force is equal to what? Ma. What type of M is that? That's M of what? A, mass A. Then what? You have your what? your acceleration. Remember, acceleration, the acceleration is not given. The little acceleration produced by that force can be calculated. Now this is equal to, this is going to be, what's the tension? The tension is not given. Remember, your tension f of t is what we have to calculate. What's f of f? F of f is frictional force, and that's what? 50. And what's our m? Our m is 10. Then times what? Times what? A. You are going to have this to be what? F of t minus 50 is equal to 10a. Take note of this. So here we can make A the subject of the formula here. Let's make it, because it's f that we have to calculate. Then we have your A to be equal to ft minus 50 over what? Over 10. Take note of this equation. Now let's come back to this second one, this mass here, mass B. Now if you look at mass B, for this object, for it to accelerate downward, remember that the weight of this object, for the weight of this object W, as seen in this analysis, this one is going up, this one is, for this object to still accelerate downward, it means this weight is greater than this what? This force of what? Force due to the tension. So we have two forces that acted on this also, the weight and the what? Force due to the tension. So what we are going to do in this now, let's rule this place. It means here the sum of the forces here, force on B is equal to weight of B minus force due to what? Tension, and that's going to give us what? M what? M of B, that is M of B, then what? G. What's our this? Remember, this is weight, right? So we are going to have it to be WB, that is weight minus what? FT is equal to MB. Remember, we are dealing with B, then what? G. This is going to be MBG minus FT is equal to MBG. MBA, this is A, sorry. Remember, this will give us the sum of the forces that act on B will produce the acceleration undergone by what? By B, or undergo by what? By B. So this place should be acceleration, this place should be acceleration. Now what's this? The mass is what? 15. And what's this? This is what? G is what? 10 minus your FT. Your FT is what you are calculating for. What's this one? Your MB is still 15 what? A. Now if you multiply this, you are going to have your 15 times 10 is going to give you what? 150 minus FT is equal to 15A. So let's make A the subject of formula here. Then we are going to have our A to be equal to 150 minus FT over 15. At this point, this is equation 2. Now we can now consider the two equations. Consider the two equations. Now to consider the two equations, we equivalent the two together. If we equivalent the two together, we are going to have our, remember the first one is FT minus 50 over 10, and is going to equal to this, and that's 150 minus FT over 15. Now if we divide this is going to be what? We have this to be 2, 5 in this, 2, 5 in this, 3. So if we multiply, we are going to have, here we cross multiply, we have our F. If we cross multiply this, we multiply this, we have 3FT minus 3 times FT, you have 3FT, 3 times 50, we have what? 150. Then here you have 2 times this, you have what? 2 times 150, you have 300 minus 2FT. Now at this point, collect the like times. You are going to take this one to this side. That's what? 3FT plus 2FT is equal to 300 plus 150. And that's going to give us, this is going to give us 5FT is equal to 450. So divide both sides by what? By 5. You are going to have 450 divided by what? 5. Then you are going to have this to be Ft to be equal to 450 divided by 5 is going to give you what? 90 Newton. So the tension in this string now is 90 Newton. The fourth question asks us to calculate the acceleration. Remember, find the acceleration common. Find the common acceleration of A and B. The common acceleration of A and B, all you just need to do is just to pick, they are both the same, is just to pick either you are going to pick any of either the sum of the acceleration force on A, or the sum of the forces on A, or the sum of the forces on what? B. What I mean by that is this. Let's go by this equation. Let's go by this. Let's pick any of these. If I pick this, I'll be able to calculate the acceleration they are talking about. If I pick this, it's still going to give me the same answer. So let's pick this. So we are going to say, therefore we have our A from 1 to be equal to Ft minus 50 over 10. And that's going to give us 90 minus 50 over 10. So this is going to give us 40 divided by 10. And this is going to give us 40 divided by 10. Well done. And we are going to have 40 divided by 10. Remember, our Ft is Ft minus 50 over 1 over 10. So our Ft is calculated to be 90. Then we are going to have this to be equal to 90 minus 50 over 10. And that's going to give us 40 over 10. And this is going to give us 4 meter per second square. Our A is 4 meter per second square. Thank you. So hope you're enjoying this class, and don't forget to subscribe to this channel. Thank you.